Hello, we're Team 14204, the Super Screen Bros, and we're going to be giving you our presentation on 3D printing for your robot.
Alrighty, so first thing to start with 3D printing is your various CAD programs. So obviously, to be able to print something, you need to have something to print. So you can get models to print off of various online websites like Thingiverse or whatever. But most likely for your robot, you're going to have to actually design it yourself, so it's custom to your robot specifically. And so there's a lot of different options for CAD programs that you can use. We got Fusion, Onshape, Creo, SolidWorks. Our team personally uses Fusion 360. We like it because it has quite a lot of features and it's also free. So, because if you're a student, you can get a student license, and so that way you can. You have the perks of a paid program, but since you're a student, you can get it for free. Now, all these programs that we have here do have that, but we just personally prefer Fusion. It does require some slightly more powerful computers to run, so just be aware of that. Onshape, for example, is completely online, so you could even run that on like your phone if you wanted to. It's probably not great for actually designing stuff on your phone, but you could theoretically do it. And we don't know too much about the other two. I'm not going to go quite into that, but those are also some options.
So for 3D printing, there's a couple different types of printers. One of them is resin, which is more expensive, but it has a higher print quality. It has a lot more maintenance because when you print it, after it's printed, you have to wash it in alcohol and then you have to cure it to add strength, so it takes longer and it's just more work. How the resin printer works is that it uses a light and it solidifies the resin. There's quite a few different types of resins. There's Tough. Tough is the one we use for quite a few of our resin parts. It's the strongest and stiffest that they have. There's also Durable, which is strong and stiff. It has a lot less friction, so it's good for parts that are like rubbing against each other.
So one example is we use that for some drag chains that we printed.
And there's also Flexible, which is just flexible.
Yeah, it also has quite a bit of grip on it too. So if you wanted to make like a grabber or something, you could print out of that to like have enough grip on the parts.
So another type of printer is the filament printer. Most people have a filament printer. It's a lot cheaper than a resin printer. It has a heated nozzle that lays filament, and the printing is relatively quick.
It will be less precise though, so you won't have as nice of prints as you will with resin, though you can tune in a printer to be quite nice.
So there are a few different types of filament for the filament printer. We use PETG the most because it's impact resistant and it's just really tough in general. It can require some high temperatures to print, and the support structure can be kind of hard to remove. Another type is ABS, which we have not used, but it's very tough. It is expensive, and it can emit fumes during the print. PLA filament is good for prototyping. It requires a lower temperature to print than ABS or PETG, but it can melt easily and it can be brittle. TPU filament, which is what this is made out of, it's flexible. You shouldn't use support structure for it. And yeah, you can change the squishiness of it based on the infill. BVOH is water dissolvable, so that means you're going to want to use that for support structure.
Yeah, so you can see here the green stuff is the actual filament, and then the white is the water dissolvable stuff. And so we're using that for the support. So there's a lot of like small holes in here, and it'd be hard to get regular support out. But with this, you can just dunk it in water for like half an hour, and then it's mostly dissolved, and you can just work it out with like a plier instead of having to like break it off. So next is slicing software. So obviously once you've designed or you've found whatever design you want to print, you'll need to prepare that file for 3D printing. What slicers do is they convert STL files into G-code. G-code is just a list of commands to tell your printer when and what to do with like what part. And so that's just telling it like where to move and when to extrude and stuff. There's a lot of different slicers. There's Cura, Photon, Workshop, Prusa. You have less choice with slicers on which one you actually want to use because a lot of printers have proprietary slicers, so you have to use their slicer that they've made. Typically though, if you know how to use one slicer, the other slicers are kind of similar. So if you just learn how to use one, you should be able to use the other ones without too much hassle. So, yeah.
When you're printing, there's different settings for your prints that you can use. The first one is wall thickness. You can have up to 1 wall layer, 10 wall layers. 1 wall layer would be more for lighter prints, while 10 wall layers is more for structural prints. We preferably like to use 3 because it's a good medium between lightness or weight and structure. There's also a second mode called spiral base mode, which allowed us to create these 2 prints here. In your CAD design, you would have just a cylinder, and with spiral base, it prints just the outside layer. So with this, it's very flexible and it's made out of PETG, so it's very strong. We use this for our TSC for last year. The second option we have on here is infill. With infill, there are many different types of infill, but we have 3 here that we are going to present the most. Our first one is cubic. It's going to be the same structurally in each direction since the lines are weaving throughout. And if you can see the picture there, they're angled towards each other and every such. The second one is rectilinear. This is going to be good for strong compression, but weaker at shear force. So if you need a part that can withstand a load from one direction or compression, this would be a good infill for that. The second one is honeycomb. This is also stronger for compression, but it is weaker when being twisted due to the layer lines being just on top of each other and not like cubic with the layer lines going throughout. The third one is brims. The brims are used for if you need more adhesion to the build surface. This allows for more area that it can stick to the bed. This here is without a brim, and then on to the right is the with a brim. You don't want to use fillets when you're printing on your bottom surface. This can result in stringing and such. Chamfers are a bit better, but they might still result in stringing.
So you'd want to use a brim for if you have like a part where it's like pointy on the bottom or something, or not pointy, but it's kind of small on the bottom, so there wouldn't be much area like for this. So you see how there's not much area that would actually be on the print bed. So that's where you would use a brim, which that basically just makes it bigger out here so that you'd have more area on the bed.
So when you're printing, you want to keep the layer lines in mind, as different orientations with the layer lines can lead to breakage at certain points. The prints usually break along the layer lines due to core adhesion. There's different ways that you want the layer lines to go. So just for example, this piece here, the layer lines go this way. If you had shear force, which would be force coming from this side, you would want the layer lines to go like this to keep them from breaking. If you were pulling this print apart, having like tension on it, you would want the layer lines to be perpendicular to the force coming in. Now, printing it like this would lead to more support material, so you have to keep that in mind when printing.
So with supports are another thing you can use to your advantage. Sometimes you have to input those in the slicing software. They're normally used to hold overhangs over 45 degrees, but this can also depend on your part. One thing we say is use as few as possible because they can be kind of hard to remove and they can affect how how the print looks and the surface of the print. It also makes parts harder to put together. And just if possible, just make it so you don't need to put support structure in.
One other thing that you want to think about when you're printing is clearances. If you're going to have a part with a screw through it, such as our center grabber here, we have these smaller screws here. You want to make sure you have enough area for them to fit. So another part would be these here with these screws. You want to just make sure that there's enough area, as well as these threaded plates. If it is too tight, you won't be able to get it to fit. If you have no clearance, it's going to be hard to get in. If you have a 0.25 millimeter gap, it's going to be a lighter press fit. And then if you have a 0.5 millimeter gap, it's going to be a clearance fit, which we prefer 0.5 millimeters more for our parts. This can also vary for your printer settings and quality and such.
So through holes. If you want a screw to go through your part, you have to make a through hole for it. A clearance fit for an M4 screw for your through hole would be 4 millimeters plus a 0.5 millimeter for a clearance fit, and then so that would make a 4.5 millimeter hole size. Be sure to add a nut on the other side to keep your parts together.
So threaded inserts. These are another way of attaching parts together. We have threaded inserts in various parts of our robot, like here, there's threaded inserts in here that screw, you put a screw through the bottom of here and it threads into there. These are good for parts where you want a lot of strength on them. So, yeah, with these though, you do have to pause the print in order to put them in. There are some like this where you can leave a slot, but that reduces the strength on the part. Another example of threaded inserts would be heat set. These you would make a small hole in your print, like before you print it, and then you would use like a soldering iron almost to heat these up, and then you push them in, and then it melts the plastic to secure those in place. Threaded nuts or embedded nuts would be better for strength because they won't get ripped out as easily.
So one note on embedded nuts is that what you do for this is we use some square nuts for ours. You don't have to necessarily use square nuts. We just find it just easiest to put those in because they're not like hexagons and they're not gonna get rotated in there and get caught in your hole. So, but what you have to do is you have to design a rectangle in your part that's completely inside and have that be cut out. So that way you can get the nut in there. And so what you do is you print up until you get to the top of that rectangle that you've made, and then you pause the print. A lot of software, a lot of slicers let you do this, so you can set it so it pauses at this point. And then you put in these nuts, and then you get it to print again, and it prints over top of that. So that way the nuts are like, it just makes it really easy to screw into the part because you know that the threads are there, and you don't have to worry about like putting up a nut on the other side, and it just makes assembly a lot easier.
So then for threading directly into plastic, this generally is not recommended for structural parts. You do want to make sure the filament is not real because if it is, it can crack and then the parts are basically ruined. You want to add a hole size of the screw's minor diameter. So minor diameter would be the size of the screw minus the threads. Coarse threaded screws should be used, and they should also be self-tapping. Self-tapping basically means that it acts almost like a drill bit. So it'll drill its way in there and create its own threads as it goes in. This will increase strength and keep the screws from being ripped out.
Alrighty, so uses for printing. So printing allows you to just create a lot of parts a lot faster than any other way. So like if you were to get parts manufactured by some manufacturing company that does whatever they're called. there's companies that let you send them files and then they'll make it for you. So, but printing is a lot faster than doing that, because obviously you have to send them the file and they print it, or, design it or cut it or whatever, and then give it to you. So printing is just a lot faster than that, because you do it yourself, and that's very useful for prototyping and making a lot of prototypes to see what will work. It lets you create completely unique parts, which is useful, especially for robots, because a lot of times you need just a part specifically for your robot that you're not going to be able to find anywhere. And so you're going to need to either 3D print that or manufacture it some other way. And it's also good for making lighter parts, because they are obviously plastic. Plastic is relatively light, and you can control how dense your part is with the infill settings. And it just it can make it easy to have parts to assemble the robots. So some examples of stuff that we've printed would be like, everything on this table. So like our grabber here, this is almost entirely 3D printed ourselves, aside from the servo and the shafts here. But we've 3D printed like the housing for the servo, as well as for the cam and stuff like that. The cam itself is 3D printed. So, and the squishy part. So the way this works is we have a squishy part in the middle here. We have a squishy part going around here with a cam in the middle, and that cam can rotate and it pushes us out. So we use flexible filament, the TPU. We use that for the ring here, and then we use PETG for the rest of it where it needs to be structural. This part is a good example of the different printing techniques, because we have embedded nuts, we have threading into plastic, we have all different kinds of infills and stuff like that.
Another example that we have is our number plate lights. These allow us to have lights within our number plates, so they can tell the drivers different information, such as time to match and all that. We have holes in our plates that the lights go through, and then these number plates are laser cut, and where the numbers are diffuses the light to then make it more readable. We also use our number plate lights to hold on these little resin printed parts. Inside there are 2 lights that allow us to have forward and reverse lights. With 3D printing, we were able to do a lot of this customizability for our lights.
Yeah, basically all the green parts on this robot are 3D printed with various techniques.
Another part that we made by 3D printing is our odometry pods. These were custom designed, and we were able to rapidly prototype our odometry pods.
Yeah. So what these do is we use a rev through bore encoder, and so we can put these in here, and then we also have a spot for a wheel to be in here, and so that way we can have a nice self-contained odometry pod, so that we don't need to worry about manufacturing anything aside from the printed part.
So a useful resource for teams that don't really have access to printers is CrowdForge, which it lets a team ask for a part, and then a nearby team that has like a 3D printer, laser cutter, or CNC router make a part for the team that doesn't have like any of those resources. Yeah.
Does anybody have any questions?
So while we think of questions, let's go back to CrowdForge real quick. So this is made by Technophobia, Robotheosis. They're trying to just make it so that more teams can have access to these manufacturing techniques that are maybe too expensive to do, to like buy your own 3D printer or whatever. So I think this is a really cool idea. It does require people to be able to sign up and be willing to print stuff or cut stuff for other people. So Please sign up. I think it's a great idea, but it only is gonna work if everyone does that.
Any idea how many people are signed up now? That is a great idea.
I don't know. We're signed up. That's at least one.
Can you cover the resin prints like on last year's robot, all the resin stuff you printed?
So this here's our Freight Frenzy robot. And for our intakes here, we've got two wheels from AndyMark, and our center wheel is resin printed. The reason we wanted it to be resin printed is the flexible filament has a lot of grip to it and can flex whenever taking in the cubes or balls for that season. With that, we were able to customize it very much to what we needed and stuff like, we also have our resin printed lights up here. These were able to also give us information. The resin print helps to diffuse the light, making it easier for the drivers to see, so that there isn't confusion between is it on or is it off.
Yeah, because it's a really small light that's on here, but with these diffusers, it makes it so that the whole thing is lit up, which is very nice. And we also have, the other resin printed thing we have on here is the drag chain on the back here. So it's this gray piece right here. We use that for our wire management. That's resin printed specifically because we needed it to be a very precise print, because there's very low tolerance with this. So we need it to be like really small layer lines, and that's exactly what resin printers are good for. So that was pretty perfect. We use the what
Formlabs. Formlabs.
Yeah, we use a Formlabs resin printer.
Another example is our center rubber yet again. All these parts here we wanted them to be small. So our resin printers with its high quality makes it easier to print small things. As well as that, our cam inside is also resin printed, as it needed to be able to fit into a very small area that resin printers can't just really get to the quality of, or filament printers can't get to the quality of.
Yes?
Yeah, question is for your resin printing, what's the resolution you use? What do you think is enough, is 2K, 8K or something like that? What's the resolution?
So the Formlabs printer is a laser printer, not a
Projectors.
projector-based printer.
Yes, I mean, it uses laser, right?
Right.
Yes.
So
So what it does is it has a laser that can slide across. It actually, like, the laser itself moves across. So that way, there isn't really resolution with that so much.
there is. So the layer lines, you can go down to 0.05.
Oh, yeah.
Is that's the layer height. So I think some resins you can go to 0.025. Maybe. I'm not sure which resin that is. But a typical filament printer can go down to like 0.1 usually. 0.2 is kind of normal. So it's quite a bit more precise than a filament printer.
One unique technique that we use for our forward burst lights, these are actually cured in water instead of herb. Yeah, cured in water in the curing station, which the result was this frostiness, which helps with diffusion for light.
Yeah, because we were worried about breaking the rule of having directed lights. So we printed those things to like diffuse it so it's not like shining at you.
What's your favorite part you 3D printed on your robots?
Well, we got quite a few. You guys have anything?
Personally, I like our odometry pods, just because I think it's cool that we custom made our own odometry, and we were able to get them to work really well.
Yeah.
With our odometry pods, it is one piece that we slide the rev encoder into, and then we have the wheel here, and our springs allow for very good tension against the field, so it doesn't slip on the field. There's also a second piece that is printed up in the top, which is the stopper for our odometry, so that it doesn't go past this point.
My personal favorite part would probably be this one, which obviously isn't on a robot anymore, but it was on the earlier iteration of this robot. We call it the scoop. It goes on the front, so the idea is that the wheels go and push the blocks and balls up this. And that's not, the function of it isn't really why I like it. It's because we started designing our robots like fully in CAD that year. Well, we started doing that at the beginning of the season. And so because we had the full robot designed, I was able to go and design this and print it and have it work first try, perfect spacing and everything, without having to go back and make a bunch of iterations on it for just like small, different like sizing changes.
And that's an example of PLA, right?
Yes, we actually printed this in PLA because we didn't think it was gonna work first try. And then it did, so.
If you're looking to get into 3D printing, there's some really cheap options. I personally have a printer that was around $250, and the print quality is very good for the price. So 3D printing is becoming a lot more affordable if you guys are looking to get into it.
What printer is it?
It's an Ender 3V2.
Yeah, there's a lot of very good guides and stuff online as well for you to figure out how to design stuff and slice stuff and which printer you want. So there's definitely a lot of resources online that you can use if you have more questions.
Or you can get a hold of us, right?
Yep.